Hi, welcome to Unit 5, Day 9 practice. In this video, we're going to go over strategies for balancing double displacement reactions, specifically precipitate reactions. What are some good strategies that we can use? So before we begin with that, I just want to quickly remind you of what balancing equation sort of looks like. When you're balancing equations, you're trying to get the same number of atoms on both sides of the reaction arrow. And the first thing that we do is we take a tally, or we count the number of each type of atom on the reactant side and on the product side. And then we change the coefficients to get them to balance. Now, in the case of like example 1, this is sort of the typical thing that we would see. So we start off with listing the number of each atom. So we have sodium, we have 2 of them. For sulfur, we have 1 iron, and 2 chlorines. And then we will repeat that on this side, so I'll just do it in the same order. Sodium, sulfur, iron, and then chlorine. And then I say I've got 1 chlorine here. I've got, 1 sodium here, 1 chlorine. I've got, oops, I'm missing something here. 1 sulfur, and then 1 iron, right? And then I would change the coefficients to get them to balance, okay? So this is typically what we would do. And this first example is what we've seen before, so it's not a big deal. But when we get into reactions where we're dealing with polyatomics like nitrates or ammonium or whatever, it can get quite tricky. Notice how in the case of the nitrate, we have to break that apart into nitrogen and oxygen. And since the nitrate stays together on both sides of the reaction, there's really no need to break it apart. Now, this may seem like, oh, that's not a big deal. I can just easily break that apart. But wait till you get to something like this, where you have ammonium and you have nitrate. And both of these have nitrogens in them, and you've got to distribute that subscript. It can get really complicated. In fact, I made a mistake when I was counting my nitrogens because I forgot I had a nitrate over here, right? And I had to distribute that too. So this can get really complicated. So we're going to go over some strategies. The first example 1, is something that we've seen before, so there's really no strategy that we can employ here, but it's a good review. So recall that the first thing we're going to do for these precipitate reactions, what we've done, we've already broken things down into their cations and anions, and we're going to treat the cations and anions as groups, and that's what we're going to list here, not necessarily the atoms themselves, but whatever our cations and anions are. So on the reactant side, our first cation is sodium, and we have 2 of them. Next, we have our first anion, that's sulfur, and we've got 1 of those. And the next cation we have over on the reactant side is we have an iron, we've got 1 of those, and chlorine, we have 2 of those. Okay. So we're going to do the same thing on the product side, and I like to keep it in the same order. So sodium and sulfur, I'll just rewrite my cation and anion groups, and then I'll count them. So sodium, we've got 1. Sulfur, we have 1. Iron, we have 1. And chlorine, we have 1. Okay, so now that we've done that, now what we need to do is we need to change coefficients to get things to balance. So taking a look at this, I see the sodiums are not balanced. I have 2 on the reactant side and 1 on the product side. So to get that to balance, I need to change the coefficient in the compound that contains sodium on the product side. So I'm going to change that to a 2, because that would multiply that. That means I have 2 sodiums. So that changes the number of sodiums to 2. I have 2 sodiums. And since this compound also has chlorine in it as well, I have to change the number of chlorines to 2, since I have 2 sodium chlorides, okay? So now I'm just going to go back and check, and it looks like everything is balanced. 2 sodiums on both sides, 1 iron on both sides, 1 sulfur on both sides, and 2 chlorines on both sides, okay? So that's typically what we do. That's pretty straightforward. So now we're going to use the strategy here. In this next example, you really see the strategy come into play. So for this strategy, the main thing is you're going to keep the cations and anions together. So if you have a polyatomic, you don't break that down into its atoms. Just keep that together when you're listing out your tally. So we're going to start with our first cation is silver, Ag, and I've got 1 of those. My first anion is nitrate, NO3. I'm just going to list it as NO3 all together. You don't even need to write the charge of the nitrate because we're just focusing on number of atoms here. So, and I only have one of those. Now I only have one because there's no parentheses around it, right? Do the same thing for the second cation, potassium. I've got one of those, and then iodine, I've got one. Okay, great. So this looks good. So now I'm going to do the same thing on the product side, and I'll do it in the same order. Ag, NO3, K, and then I. So we've got one Ag. We've got one NO3. Again, there's no parentheses around it, so I know we only have one of those. One potassium and one iodine. This reaction is balanced. Okay, let's do it for the next example. We've got NH4 is our first cation. And notice that we have a parentheses around it. So the number outside the parentheses, that subscript, tells me that I have two NH4s. My first anion is sulfur. I've got one of those. My next cation is lead. I've got one of those. And then how many nitrates do you think I have? Well, I've got a parentheses around it and a 2 on the outside, so that means I've got 2. Remember that number on the outside of the parentheses tells me I have 2. All right, so now we're going to check it out on this side. And again, I'm going to write it in the same order. It just makes it easier, but you don't have to. So NH4, sulfur, and then I put lead. And when I say the same order that I've written it here, so NH4 and then S underneath it, that's how I'm doing it. You don't have to do that, but for me, it just makes it easier when I'm comparing them. All right, so on this side, I have one NH4, and I know I only have one because there's no parentheses around that polyatomic ion. For sulfur, if I look over here, I only have one sulfur. For lead, I have only one lead. And the nitrate, there's no parentheses around it, I have only one. Remember, for polyatomics, if you have more than one, there's a parentheses around it. Okay, so now comparing them. My ammoniums, NH4s, are not matching up. So I have 2 on this side and 1 on that side. So in order for me to get 2 on this side, remember I have to change the coefficients. I can't put parentheses around it and change the subscript because that would make the formula incorrect. So the only thing I do is change the coefficient in front. So in front of this compound, I'm going to put a 2 as my coefficient. All right, so that changes the number of ammoniums now, NH4s, to, I have 2 of them now, since I have a coefficient of 2. That also changes the nitrate in that compound. So since I have a coefficient of 2, that means I also have 2 nitrates as well. Okay, so let's go ahead and check everything. NH4, it's looking good. Leads are the same on both sides. Sulfurs and nitrates are the same. All right, let's do the last 3 examples. So here, we're going to divide this into zinc, nitrate, sodium carbonate. I have 1 zinc. I have 2 nitrates because there's a parentheses outside that nitrate. I have 2 sodiums. That subscript outside the sodium tells me that. And I have 1 carbonate. We're going to get the same, we're going to get our tally on the product side. Sorry, CO3. Okay, so I've got 1 zinc. I've got 1 nitrate. I've got 1 sodium. And I've got 1 carbonate. All right, so looking at this, my zincs look good, but my sodiums don't, so that's the first thing I'm going to try and balance. So if I got 2 on the reactant side and I only have 1 on the product side, I'm going to change the coefficient in front of that compound that has sodium in it to a 2. That changes the number of sodiums to 2, and it changes the number of nitrates to 2, since that molecule also has nitrate in it. All right, check the rest of it. Everything looked balanced. That one's good. So the only thing I need to do is change the coefficient in front of nitrate there. All right, next example, barium, chlorine, copper, and sulfate. All right, I've got 1 barium, 2 chlorines, 1 copper, and 1 sulfate. And on this side, I've got 1 barium, 2 chlorines, copper I have 1 of those, and sulfate I have 1 of those. All All right, so to change, to get it to balance, the bariums look good, the coppers look good, the chlorines look good, and the sulfates look good. This is already balanced. Last example, aluminum, I have nitrate, I have potassium, and I have hydroxide. All right, let's get our tally. I've got 1 aluminum. I've got 3 nitrates. It's the number on the outside of the parentheses that tells me I have 3. I have 1 potassium, and I have 1 hydroxide. On this side, let's check it out. I've got 1 aluminum. I've got 3 hydroxides. And I've got 1 potassium and 1 nitrate. Okay, so looking at this, it looks like the aluminums are balanced, the potassiums are balanced, but the nitrates and the hydroxides are not balanced. So on the, let's start off with the, which one do we see first? The nitrate. The nitrate is imbalanced. So I've got 3 on this side, but only 1 on that side, on the product side. So to change that, I'm going to change the coefficient in front of potassium nitrate to 3. So that will give me 3 nitrates. But it also changes the number of potassiums to 3 as well. So I got 3 of those. And then finally, so the nitrates are looking good now, but now my potassium and hydroxides are still messed up. So on the product side, I have 3 potassium and 3 hydroxide. On the reactant side, I just have 1 and 1 of each of those. So I need a coefficient of 3 in front of potassium hydroxide. And that changes that, and now this is balanced, okay? So the main thing here in terms of balancing the equations, they look pretty much the same as you've done before, but you're going to, instead of breaking everything down into its atoms, treat your cations and anions as groups, and that's how you will list them. So if you have a polyatomic, list it all as one group. Don't break something like ammonium down into nitrogens and separate hydrogens, all right? That's it for this video. You will have the answer key for the CFUs on the bottom. I won't show you how to do them. I'll just give you the answer key in this document so you can check your answers. All right, have a quality day.